Wikibooks, Circuit Theory, all chapters. Shows the Circuit Series free library. There's a Wheatstone resistor bridge. Alright, introduction. What is this book? This is the first course of Secret Analysis, usually accompanied by the set of labs, assumed for level 3 with a different way. Alright, what this book will cover, what goes from here. Basic terminology. There are a few key terms that do not understand with the beginning of the book before we can continue. The only partial list with all the terms will be used throughout this book, but the key words are important to note whether before beginning with the main narrative of the next text. Time domain describes the graphs of power, voltage, current that depend on time. Simple another way of saying that the circuits change with the time of the major variable we use to describe the system as time, and another sign is temporal. Frequency, the domain with the graph of the power, voltage, current depending on the frequency of the boat. Plots, variable, the frequency of the wireless communication, and represent change channel, the data channel after another, or the Fourier domain. Other domains engineers might encounter are the Laplace domain, or the S domain, commonly complex frequency domain, and Z domain, which combined with this time is also called spectral waterfall. Circuit response generally have the input outputs. In fact, they say that the circuit isn't useful if it doesn't have one or others useful, usually both. Circuit response is relation between the circuit input with the circuit output. With the circuit response may be the measure for either the current or voltage. Non-homogeneous circuits are described with the equation with the capture for the component with the characterized with the wire together. These equations are non-homogeneous in nature. So if the equation relates and requires splitting of a single problem on the two problem, the steady state solution, particular solution, and a transit solution, homogeneous solution. Alright, steady-state solution, find value of the circuit elements of the constant periodic behavior is also known as steady-state value of the circuit. The circuit response to steady state when voltage currents have stopped changing due to disturbances, also known as steady-state response. Steady-state solution is particularly integral, is called the particular solution. Transient event and short-lived burst of the energy system causes a sudden change of state. Transient means momentary or short period of time. Transient means energy circuit suddenly changes with the cause of the energy storage elements to react. A certain circuit energy states is forced to change. When a car goes over the bump, it can fly apart, fly like a rocket cushion. The impact of the design man, but the goal of circuit of the design is to plan for the transition, whether intended or not. Transit solution determined assuming the driving force function is zero creates a homogeneous equation, which is known as a homogeneous solution. Summary: when something changes with the circuit with a certain transition period before a circuit settles down, reaches fine value, response to circuit has before setting a steady state response known as transient response. Using Euler's formula, complex numbers, phasors, and S-planes, homogeneous solution technique will develop the capture transit response, assuming the final state has no energy. In addition, particular solution techniques will develop that finds final energy state, adding together predicted circuit response. The related different equation development of homogeneous particular solution will be avoided. Variables and standard units. Electrical charge or coulombs. Electrical charge is physical property of matter caused by the experience of the force near other electronically charged matter. The electric charge, sometimes used as Q, is measured as a standard instrument called coulombs, which are abbreviated letter capital C. When the electric charge is number of electrons times E 1.610 to the 19th, hence the new number of electrons is equal to 1 over the electrons and coulombs. The coulomb has the total charge 6.241509 and some odd 10 to the 18th electron has a single electron charge of 1.602 to 10 to the 12th coulombs. It is important to understand the concept of the chain charge associated with static electricity. Charge is a concept of the physical boundary with related to the counting a group of electrons flowing electricity in an entirely different situation. Charge and electrons separate. Charge move at the speed of light, while electrons move at the speed of 1 meter an hour. This most circuits the analysis chain charge is an abstract concept related to energy and electron, more related to the flow of information. Electric charge is the subject of many fundamental Coulomb laws and Gauss laws, static electricity, but it's not used with much circuit theory. Alright, voltage. Or volts. Voltage is the measure of work required to move a charge from one point to another electrical field. The unit volt is defined as joules per Coulomb. So you have voltage over W over the voltage equal to the work over the amount of charge. Charge is static electricity concept. The definition of the volt is shared between the static and flowing electrons. Voltage is sometimes called the electrical potential because of the voltage represents the difference between electric motor force that can have the produced current in a circuit. The more voltage, more potential for a current. The voltage also cover the electrical pressure through the far less common. Voltage is measured for the absolute, but in is measured in not measured in absolute, but in relative terms. English language tradition obscure. For example, what is the distance of the New York City? Clearly implied relative to the distance when we are standing in New York. But if we say what is the voltage at blank, what is the starting point? Voltage is defined between 2 points. Voltage relatively where 0 is defined. We say the voltage from A to B is 5 volts. It is important to understand electric motor force, and voltage has 2 different things. The question is asked, what is the voltage of blank? Look for the ground symbol of the circuit diagram. Measure the voltage from the ground to blank. If the question is asked the voltage from A to B, then put the red probe on A and black probe on B and not ground. Absolutely referred to electric EMF as electric motor force. The difference between electric motor force is voltage. Current amperes. Current is measurement of flow of electricity. Current measured and called amperes. Ampere is the charge of the volume of the velocity. Same way water current can be measured cubic feet of water per second, but current is a base of standard instrument unit. Fundamental to dimension in reality, like space-time and mass. Coulomb and charge is not. Coulomb is actually defined in terms of the amperes. Charge of Coulomb is derived in standard instrument units. Coulomb is a fictitious entity left over from one fluid to a two-fluid philosophy in the 18th century. This course is about flowing electrical energy found with all modern circuits. Charge, volume, velocity defined by the current is a useful concept, but understanding no particular use of energy. Do you think that current is bundling electrons? Current carrying energy through a wire. Special relatively quantum mechanics concept necessary to understand how electrons move 1 meter an hour through copper. Electromagnetic energy moves at the speed of light. Amperes abbreviated at uppercase A. The variables most often associated with the current is letter I. Lowercase in terms of coulombs as an ampere is coulombs and amperes is equal to I guess the distance time the charge, distance time the time. Basic, widespread, complex numbers with electrical energy. In common electrical energy text, use the lower letter J as an imaginary number instead of lowercase I is commonly used with the math books term. The wiki book adopted J as an imaginary number to avoid confusion. Energy and power. Electrical theory is about energy storage and flow of an energy circuit. Energy is chopped up arbitrarily, something that doesn't exist, accounted by called the Coulomb. Energy per Coulomb is voltage. Velocity of the Coulomb is current. Amperes together they use the energy, velocity, or power unreal of the Coulomb disappears. Energy is measured most commonly in joules, which is abbreviated with J, uppercase, the very most commonly used energy, W, lowercase w, with the energy symbol W, which stands for work. Thermodynamics point of view, all energy consumed with a circuit is work. All heat is turned up into work. Particularly speaking, this is not true, but they are true in computers were never consume any energy and never heat up. The reason for that energy going into the circuit, leaving the circuit, is considered work because of the thermodynamic point of the view. Electrical energy is ideal. All of it can be used. Ideally, all of it can be turned into work. Most introduction to thermodynamic courses assume that electrical energy completely organized has an entropy of 1. Power, correlated concept of the energy being work is the energy and power circuit that can be accounted for the sum of all of the power entering the leaving the circuit showed adds up to 0. No energy is accumulated theoretically. Of course, capacitors charge up and may hold into their energy if the circuit is turned off. Inductors will create magnetic field containing energy that will instantly disappear back through the source for which the switch turns off the circuit. The course uses what's called passive sign convention. Power energy put into the circuit by a power supply is negative. Energy leaving the circuit is positive. Power of the flow of energy computation is an important part of this course. Symbol of the power is W for work. The units are in watts, capital W. Electrical circuits basics. Circuits, also known as networks, collection of circuit elements or wire with a designated with a schematic being with a straight line node with a location schematic with two or more wires connecting, usually marked with a dark black dot and dark black dot. Circuit elements are everything else, and some of the most basic circuit elements are often simple, easily recognizable, although some of the drawn in a simple box image with specification of a box written somewhere that easy to find. We will discuss several of the types of basic circuit components of this book. Ideal wires. For the purpose of this book, we assume that the ideal wire is zero total resistance, no capacitance, no inductance. A consequence of these assumptions is that these ideal wires are infinite bandwidth and immune to interference and are in essence completely uncomplicated. Not in the case of the real wires, because all wires have some amount of the associated resistance. Also, placing multiple real wires together and bending real wires in certain patterns will produce small amounts of the capacity and inductancy, which can play a role in circuit design. Analysis book assumes that wires are all ideal. Ideal junction and nodes. Nodes are called the junction of the book in order to make the distinction between the node analysis. Kirchhoff with current low with a discussion about physical node itself. The physical node is discussed. A junction with a group of wires to share the electromagnetic force, not voltage. Ideally have two resistance. All wires have touch wire with somewhere as part of the sum node. For the diagram right, show the two big blue nodes, two small green nodes, and two trivial one wire touching red nodes. Sometimes the nodes described in two or more wire touches. Student circles where the wires are intersect calls the node, but they only work with a simple circuits. One node is labeled ground with a circuit drawing before the volts is computed with the circuit simulated. Typically, this is node having the components connected logically, normally placed on the bottom of the circuit logic diagram. Ground is not always needed physically. Some circuits are floated on purpose. Node quiz. Measuring instruments. Volts and ammeters devices used to measure voltage across elements with the current flowing through the wire, respectively. Ideal voltmeters. Ideal voltmeter has infinite resistance relatively several of the mega ohms, acts like an open circuit with voltmeters placed across the terminals of the circuit element will determine the voltage across the element. In practice, the voltmeter siphons enough energy to move the needle that causes the thin strips of metal to separate with turn on the resistor so the number is displayed. Ideal ammeters. Ideal ammeter zero resistance acts like a short circuit, but the ammeters require cutting the wire with plugging the two ends of the ammeter with in practice with the ammeter placed like tiny resistors in the wire, measuring the tiny voltage across the ammeter, measuring the magnetic field strength generated with the current flowing through the wire. Ammeter is not used with much because of the wire cutting or wire disconnecting they require. Active, pass, reactive. The elements are capable of delivering energy but capable to amplify the signal are called active elements. All power supplies fit in the category. Elements will receive the energy dissipated is called the passive element. Resistors model these devices. Reactive elements store or release energy into the circuit. If the ideal they don't consume the generate energy. Capacitors and inductors fall into the category. Open short circuits. Open, no current through the open. No current flows through an open. Normally an open is created with a bad connector, dust, bad solder joints, bad crimping cracks, and circuit board traces create an open. Capacitor responds to DC by turning opens after discharging. Uncharged inductors appear as open immediately after powering up a circuit. The word open refers to a problem description. Word open can also help with developing an intuition about circuits. Typically, the circuit stops working on with the opens because 99% of all circuits drive with a voltage power source. The voltage source responds to open with no current. Opens with equivalent of the clogs in the plumbing, which are stopped water from flowing. On one side of the electric motor force will build up just like water pressure building up on one side of the clogged pipe. Typically, a voltage will appear across the of the open. Short. Voltage source responds to a short, delivering as much current as possible. Extreme example of this can be seen as the ball bearing motor vehicle on a YouTube video. Motor applies a short to the battery. The donut he only completes the short a short time, worried about the car battery exploding. Maximum current flows through the short. Normally a short is created by a wire, nail, or some loose screw touching parts of the circuit unintentionally. Most component failures start when the heat build up. Heat destroys varnish and paint insulating, creating a short. The short causes the most of the current overflow, causes more heat. The cycle that repeats faster and faster until the puff of the smoke. Everything breaks, creating an open. Most component failures start with a short, end in an open as they burn up. Feel the air temperature above the circuit component after the power on. Build the memory of the normal operating temperatures are. Cold can indicate short has already turned into an open. Uncharged capacitor initially as appears short immediately in powering circuit. Inductors appear in short DC after charging up. Short concepts also help build an intuition, provides opportunity to talk electrical safety, helps with the described component failure modes. A closed switch. Throughout, the short switches are surprisingly complicated to study. Switches with the term closed begins to dominate the short. Resistors and resistance. Resistors. Mechanical energies to model everything in a spring with the electrical energies compares to everything in the resistor. Resistor circuit elements for the resistor flow current. This is divine voltage appears across the resistor and two wires appear resistant electrical energy and heat with the device similar to the resistor turn with the energy into light, motion, heat, and other forms of energy. Shows a resistor symbol. Current drawing above the shows the enter of the positive side of the resistor. Resistor does not don't care the leg connected to the positive or the negative. The positive means positive red diode voltmeter placed on the positive reading. This is called the positive charge flowing sign convention. Some circuit theories, often in physics-oriented curriculum, are taught with an electron flow signal convention. In this case, current entering the positive side of the resistor with removing the energy into the circuit as removing the energy from the circuit. With the good of the goal of the most circuit is to send the energy to the word over the form of motion, light, and sound, etc. Resistance is measured by the terms called ohms or volts per amp, the commonly abbreviated with the Greek letter omega. Ohms are measured quantities impedance reactance described later chapter variable. The most commonly represent the resistance or R or capital R. Resistance is defined as resistance as the resistivity of the material times length of the resistor over the cross-sectional area of the resistor. Conductancy. An inverse resistance conductancy unit, Siemens, submitted referred to as mhos or ohms backward, abbreviated with the upside down omega. The associated variable G. Both calculators, computers, conductance help reduce the number of hand calculations had to be done. Now, conductancy-related concept of the admittance of the suspectance can be skipped with MATLAB or active Wolfram Alpha or other computing tools. Learning one or more of the computing tools is not absolutely necessary in order to get through this book. Resistor terminal relation. The drawing of the right is on a battery and a resistor current leaving the positive terminal of the battery. The means of the battery is turning chemical potential energy with electromagnetic potential energy, dumping the energy into the circuit. The flow energy as power is negative. Current is entering the positive side of the resistor even though the positive has not been put onto the resistor. But this means electromagnetic potential energy is being converted into heat, motion, light, or sound depending upon the nature of the resistor. Power flowing out of the circuit is given in the positive sign of the relationship to voltage curve of the resistor V. Current through the resistor I, the value of the resistor R is related to Ohm laws of voltage over times resistance times amp. The resistor, capacitor, and inductors only two wires attached to them. Sometimes it's hard to tell them apart. In the real world, all three have a bit resistance, capacitance, and inductance in them. Unknown contexts called two-terminal devices. In more complicated devices, the wires grouped in ports. Two-terminal devices express Ohm laws when current and voltage is applied is called the resistor. Resistor safety. Resistors come in all form. The most have the maximum power weighting watts. If you put them through them, they can melt and catch fire with the etc. Resistance, electrical passive element that opposes the flow of electrons. Resistance to the electrical passive element that opposes the flow of electrons. Air is considered as one of the resistance sheath of the resistant lighting arresters and also vacuum sheath of the resistors. Example, some of the voltage curve of the resistor of the two-terminal is 10 volt with a measure for the current of 2 amperes when the resistance of the volt is equal to the amps of the resistance is equal to the volts over the amps, or 10 volts over the 2 amps equals 5 ohms. Resistive circuit analysis techniques. Resistive circuits. Circuit theory. Resistive circuit analysis. Source transformation. Source transformation. Independent current sources can be determined to independent voltage source, the vice versa. The method is called source transformation. Transformation useful solving circuits. Explain the two most important source transformation: Thevenin source and Norton source. We explain how to use the conceptual tools for solving the circuits. Resistive circuits. When you have been introduced to passive circuit elements such as resistor sources and wire, we are going to explore how complicated circuits, even the components, can be analyzed. Black boxes. A circuit, any other system for that matter, may be considered a black box. If you don't know what's inside the system, for instance, the most people with the computers in like a black box becomes they don't know what's inside of the computer. Most of them don't even care. All they know is that it goes into the system, keyboard, mouse input, which comes out with the system monitor and printout output. Black box's definition system and internals are known to the outside observer. The only method the outside observer has examined the black box to send input into the signals of the gauge output. Thevenin's theorem. Let's start with drawing a general circuit source with a head and a load with a block diagram. We have source to the load. Let's say the source collection of voltage source, resistance with a load of the collection resistance. Both the source and load can be arbitrarily complex conceptual states. The source directly equivalent to single source source and resistance figure A below. We determine the value of the resistance in the voltage source, so attaching the independent source to the output of the circuit as figure B is above. In this case, for the circuit source, the voltage source can also be used. The varying amperes measure voltage and voltage source resistance source. Value of the resistance can be found in the following equation: voltage equal to voltage source times the amperes times the resistance source. Value of the resistance. Two variable values of amperes will be needed. For example, for one more details easily, if the current source is set at 0, but the equivalent to open circuit voltage is equal to the voltage source. This is called an open circuit voltage, or VOC. Voltage with a base of OC with the open circuit. The important concept that allows us to model inside linear circuit, but also know the coming of the out of the truth with the concept of the Thevenin theorem with the French telegraphic energy Lean Charles Thevenin. If the circuit known now consists of the voltage over the resistance is called the Thevenin equivalent circuit. Norton's theorem. Recall above the output voltage Thevenin equivalent can be expressed as voltage equal to voltage surface of the ampere times the resistance value. Now let's rearrange the output over the ampere. The ampere is equal to the voltage source over the resistance source over the negative voltage over the plus over the resistance over the equal to voltage over the resistance value. Equivalent as CKL or CKL description following with what we call the voltage over the resistance source current IS. Equivalent current source, equivalent resistance can be found with the independent source, such as the example 2. We are above the when the above Norton equivalent circuit after Bell Labs engineer with E.L. Norton connected with the external load for the current of the source, all of the flows through with the resistor producing a requisite voltage off the terminal or voltage out. Open circuit. Also, if we were to show the two terminals on our circuit, the current would all out with the wire with the flow with the resistance current with the divider rule. Within this way, the circuit would produce the short circuit current. IS but sub I amp base SC, exactly the same as the source current amp source. Circuit transformations. You shown with the term of the Thevenin Norton circuit, the different representations, same black box circuit with the same Ohm laws, KCL equations. This means they cannot be distinguished Thevenin source of the Norton source for the outside black box. We can directly equate the two as below. We draw up the rule for the convert the two with the value of the resistor, each of the triggering condition. Conceptually identical, but could be equivalent resistance equivalent. Resistance source number equals source in source time source equation. Value of Thevenin voltage over the value of the Norton current source, the equivalent resistance Ohm lines. Voltage source equals ampere source times the resistance. These rules are valid with the circuits identical to the phi rules transform Norton circuit with the Thevenin open Thevenin circuit with the vice versa. The method of source transformation. See example 3. Open circuit voltage and short circuit current. Open circuit voltage over the voltage across the terminal current is 0. The short circuit voltage ampere is I ampere short as a base SC. Current voltage across the terminal is 0. Open voltage source question, short circuit question, short circuit current. We must observe the volume of voltage over the open circuit voltage source equal to the voltage open current. Value of Norton's current source, the short circuit current, ampere source is equal to ampere short circuit. We can say that generally the resistance equation is equal to voltage open current over the ampere short circuit of the Y-transform circuits. However, Thievenin and Norton's transforms useful? Describe a black box characteristic and a way to predict the reaction to any load found the current through the voltage graph of the device. Removing the device from the circuit of this instantly makes the complex circuit much simpler to analyze. Stepwise simplification circuit above a possible voltage source series impedance if the current sources have parallel impedance. Maximum power transfer. If we would like to transfer most of the power source loaded across the terminal as possible, how can we determine the optimum resistance load for this to occur? Let's consider the source model with even equivalent with the Norton equivalent will be led the same result, while the two are directly equivalent. Load resistance R base sub base L, the source resistance the RS, R base resistance resistor base, resistor S source, open circuit voltage source. Current of the circuit is kind of the Ohm's law. Ampere is equal to voltage source over the resistor source of resistance plus resistor load. Voltage across the load resistor is found by the voltage divider rule. Voltage load is equal to voltage source times the resistance load over the resistor source plus the resistor load. We can now find the power dissipated with the load of the power load. If our power load is equal to the voltage load and times the ampere equal to the resistance load times the voltage source squared over the resistance source plus resistant load squared. We can now rewrite to get rid of the resistant load on the top parallel. Power load is equal to voltage source load squared plus over resistance source over the square root of resistant load plus the square root of the resistant load to the second equals voltage source to the second over resistor source times resistor source and the square root of resistor source over the square root of resistor load plus the resistor load square root over the square root of resistor source squared. Assuming source is resistance not changeable, we have attained the maximum power, minimizing the bracketed part of the denominator of the above equation. The elementary mathematical result, x plus x into the negative first is a minimum when the x is 1. In this case, it is equal to 2. Therefore, the above expression is minimum under the following condition. Square root of resistance source is over the resistant square root of resistant load is equal to 1. This leads us to the condition that resistor load is equal to resistor source. We'll get the maximum power out of the source if the load resistance identical with the internal source resistance. This is maximum power transfer theorem. Efficiency. The number of electrons circuit the portion of the of all the energy dissipated with the circuit dissipated in the load. We can immediately see the maximum power to transfer the load is the efficiency of the 0.5 of the source resistor is half of the voltage across it. But we can also, for the efficiency, will increase the load resistance increase, even the power transferred if it will fall. Efficiency calculated using the following equation, and the efficiency of the circuit is equal to power load over the power load times the power source of the PS of the power source and resistor family. Use and simplify the equation. Power load, power source is equal to voltage source squared over the resistant loads times the square root of the resistant source over the square root of resistant load plus the square root of resistant load over the resistor source to the square of the graph below over the power load proportional maximum power max efficiency. Variables of resistant load between 0 to 5 of the resistance source. It is important to note the condition of the maximum power transfer. Much of the power is dissipated and source is loaded. This is not a desirable condition. For example, the source of the electricity supply system load is the electrical heater. This would mean that the electrical supply company must be wasting half the power it generates. In this case, the generator power lines, etc., are designed to give the lowest source resistance power will give it a high efficiency. Maximum power transfer condition used in usually high frequency communication systems where the resistance can be made low with the power level relatively low, paramount to much of the signal power is possible to receive in the system and the load. Resistive circuit analysis method. Analysis method. The circuit is a large and complicated, useful, but have the various methods of simplifying and analyzing circuits with no perfect formula solving Solving a circuit depending on one type of the circuit with a different method that can be employed to solve the circuit with some of the methods might not work. Some of the methods will vary difficult on the part of in long math terms. The two most of the important methods to solve within the circuits for the nodal analysis, mesh current analysis will be explained later. Superposition, one of the most important principles of the field circuits analysis principle. Superposition valid only on linear circuits. Superposition principle states the total effect of the multiplying contributing sources of the linear circuit is equal to the sum of the individual effects of the surface taken one at a time. What does this mean with the plain English? It means that we have the circuit with the multiple sources. You can turn off all but one of the source at a time, and then investigate the circuit with only one source active at a time. With every source in turn, they are added together with the effect of each of the source of the total effect. But with the principle used, must be aware of the underlying mathematics. Alright, necessary conditions. Superposition only can be linear circuit with all the circuits have a linear relationship circuit with a response. I'll use only a few alpha or break rules would build the mathematical understanding superposition. The F is taken from the response and A and B of the constant. F is equal to AX1 plus BX2 equal to F equals AX1 plus F BX2. In the term circuit with clear explaining the terms of concept superposition, each input considered individually summatively obtained with the output with a few more algebraic properties. We can see that superposition can be applied with nonlinear circuits. In the example, the response y is equal to the square root square of the input x, or y is equal to x squared, and a and b is constant. Then y is equal to ax1 plus bx2 squared, not equal to ax1 squared, but plus bx2 squared equal to y1 plus y2. Note that there's only an infinite number of the counter examples. Step by step, using superposition given the output with the breakdown in 4 steps. Isolate the circuit, select the source, setting all the remaining sources to 0. The consequence of the turning off of these sources is explained with the open and closed circuits. And somebody turning off of the voltage results in a short circuit. Turning off of the current source results with the open circuit with a response using no current can flow with the open circuit, and then they can be no voltage dropping off the short circuit to find the output of the isolated circuit with 1 over the source isolated response with the source. The question can be found using any techniques we learned so far. Repeat steps 1 and 2 with each of the source continuing short. Choose a source, remaining source to be 0. Find the response with repeat the procedure every source that has been counted for. Some of the outputs once the output due that each source has been found with add them together to find the total response. Impulse response. Impulse response to circuit E for the determined output circuit. The output of the Y is conventional with the H minus H times X input. The X is impulse the response. The input XY was the impulse, and it shows Y times T equals H minus X, or the convolution times the time, which gives a limited series of negative and positive infinity to H. The output of Y equal to HT. Knowing the impulse response to source plugged within the circuit output with the calculated with the convolution. I have not learned how to do limited series, but I'm pretty sure I'll get the hang out of it. Convolution operation very difficult. Involved with the operation combines 2 equations. Single resolving equation convolution with defined with the term of the definite integral system of such to solve the convolution equation will require the knowledge of the integral calculus. Boogie book will not require prior knowledge of the integral calculus, therefore will not go in more depth of the subject. For example, the definition, some of the light explanation. Definition: the convolution at A times B with the 2 functions A and B that define A and B times the time limited series and infinite negative infinity A times the T times B times T minus R times D times T. The asterisk operated to denote the value of convolution. Most of the computer system people that frequently write mathematics with the computer will often the asterisk to denote the simple multiplication. Asterisk the multiplication operator program language. However, the important distinction must be made here. Asterisk operator means convolution. Remember, asterisk means convolution and multiplication. Not asterisk means convolution, not multiplication. Properties: convolution is cumulative with the response A times the convolution of B is equal to B times the convolution A. Convolution distributed over addition. A convolution of B plus C is equal to A convolution of B plus A convolution plus C associated is A convolution B convolution C equals A convolution B convolution C. System convolution. Let's just say that we have the following block diagram system. where X time in the input circuit with the HT with the impulse response, YT is the output. Here we find out the output with the convulsion and the impulse response with the input circuit. Hence we say the impulse response circuit is not just a ratio and overall output input with the frequency domain, however the component of the output frequency, the wavy W is produced input with the component same frequency, transition function frequency, moral story with the output of the circuit is input and convoluted with impulse response. So XT is system input, HT is impulse response, YT is system output, and W would be frequency. Energy, XT is system input, HT is impulse response, YT is system output. Important energy storage elements, capacitors, inductors, circuit theory, energy storage, and inductors. First order circuits. Let's read capacitor and inductors. Resistor wire sources are not only with the passive circuit elements. Capacitor and inductors are also common passive elements that can be used to store the release electrical energy in the circuit. We use the analysis method we've learned previously that makes sense of complicated circuit elements. First order circuits with a circuit that contain only one energy storage element with a capacitor and inductor that can therefore be described using only as a first order differential equation. The two possible system first order circuits are resistor, capacitor, resistor, inductor. RC or RL circuits. Resistor, inductor, and resistor capacitor circuits are termed when described in the circuit that is either as a resistor and inductor RL or resistor and capacitor RC. RL circuits, resistor and inductor circuits have at least one resistor, one inductor. They can be arranged in parallel and series. Inductors can be solved by considering the current flowing through the inductor, therefore will combine with a resistive element and source the Norton source circuit. The inductor will be then externally loaded to the circuit. We remember the equation: an inductor voltage times is equal to the load times the distance of the ampere time over the distance time of the time. We apply CKL with the form positive determine the voltage source to control the following differential equation: ampere source the time equal to the load over the resistance and electron charge. Resistance over the resistor, electron distance, and amp indicator times over the distance times plus the amp indicator inductor times the time. We'll show the solve of the different equations later in this chapter. The resistor capacitor circuit with both the resistor and the capacitor, like the RL circuit, will combine with the resistor source one side of the circuit, combining with the M and the medium source, which is called then if we apply the KVL around the resulting loop, we get the following equation: voltage source equal to resistor capacitor times the distance of the volt amp capacitor times over the distance time plus the voltage capacitor time. A first order solution series of resistor equations with a differential equation series resistor inductor series of RC different equations of RC circuits. Time constant series resistor inductor resistor constant with time constant. Time is equal to the load over the resistance. Time is equal to the load resistor capacitor over 1. In general, determine the energy standpoint of the system in steady state of the voltage current is also ground level after the time period of 5 time constants. Resistant loads, resistant induction capacitor circuits. Series of resistant inductor capacitor circuits or RLC circuits. Second order differential equation: load is equal to distance amperage over the distance time plus the ampere time. Amps time the resistance plus the 1 over the amp 1 over the capacitor of the limited distributed amp the distance time equal to voltage. And then we have distance squared times amp over distance times squared plus resistant load times distance amperes over distance time plus 1 plus amps plus amps over inductance and inductor and capacitance equal to 0. The characteristic of these equations: source is squared plus resistor over the load to the source is equal to 1 over the load capacitor 0. Source is equal to negative alpha over the square root of alpha 2 minus beta 2, where alpha is equal to resistor over 2 loads, and beta is equal to 1 over the square root of the inductance capacitor, where the square root of alpha 2 squared minus beta squared is 0, alpha squared plus beta squared, and resistance is equal to 2 times the square root of the load over the capacitance. Equivalent has only one real root, and that's the source of the negative, and alpha is equal to the negative resistance over the two loads. Solution for the amperes time is equal to amperes times the amperes energy minus resistance over the two load times time. The T curve will look like the following: square root of alpha minus beta is greater than 0, and alpha squared over beta squared. Alpha squared is greater than beta squared. Resistance is greater than load in inductance and capacitor. The equivalation has the true rule source equals negative alpha plus or minus the square root of alpha squared minus alpha squared minus beta squared. Solution amperes time is equal to the energy of negative alpha plus the square root of alpha squared minus beta squared times the time, and energy is equal to negative alpha minus the square root of alpha squared minus beta squared times equal to the energy negative alpha is equal to energy times the alpha squared minus beta squared plus alpha negative square root of alpha squared minus beta squared. The T curve will look at the following: alpha squared, the square root of alpha squared minus beta squared is less than 0. Alpha squared is less than beta squared. Resistance is less than inductor over capacity. Equation of the two complex source of the equal to negative alpha plus the junction alpha beta. The square root of beta squared minus alpha squared. Solution of amperes time is energy is equal to negative alpha plus the square root of beta squared minus alpha squared T plus energies of the negative alpha minus square root of beta squared minus alpha squared times T. Equivalent is equal to energy and negative alpha equal energy of the junction of or energy joules of the square root of beta squared minus alpha squared times T plus energy is negative joules square root of beta squared minus alpha squared times T. With the ampere T curve would look like the following: damping factor is the amount of the oscillation circuit gradually decreasing over the time. We define the damping ratios to be damping ratio of the series on the RLC circuit is resistor over 2 times the square root of capacitor over inductors for series RLC. Damping factor would be for parallel RLC 1 over 2 resistors times the square root of the inductor over capacitor. Resonant frequency is equal to 1 over the square root of inductor capacitor, and in parallel RLC ampere the resistant frequency is equal to 1 over the amperes. 1 over the square root of inductance capacity comparing the damping factor, resonant frequency given the different type of the overdamped, underdamped, and critically damped. Bandwidth is equal to 2 alpha for RLC squared. The bandwidth of the frequency is equal. The bandwidth is equal to 2 alpha equal to resistance over the load. Parallel RLC and bandwidth is equal to 2 alpha equal to 1 over the resistant capacitor quality factor. The amount of charge over the bandwidth over the frequency over the bandwidth over 2 alpha equal to the inductive of the resistance over square root of LC equal to 1 over the R times the square root of the L over C. Parallel resistance curve of the the quality factor is equal to the frequency over the bandwidth equal to the frequency over the 2 alpha equal to the resistor capacitor over the square root of the inductance of the capacitor equal to the resistance over the square root of the capacitor over the inductance. Stability. Because of the inductor capacity with a different input, the sum of the potential of the circuit responds with approach infinity with substitute for the certain type of the amplitude of the input with the output circuit approach with the infinity of the circuit is said to be unstable. Unstable circuits can actually be dangerous. Unstable elements overheat, potential rupture. Circuits considered to be unstable when well behaved. They produce the well behaved output respond with a team with a well behaved different in each of the application but generally we mean well behaved to be finite controllable quantity. Resonance with a resonancy with equal to zero, the circuit reduces the shear of the inductor capacitor in circuit. Circuit is resistance resonance with the circuit will vibrate with resonant frequency. Impedance is equal to voltage capacity. The width the frequency of the inductance is equal to 1 over the frequency of the capacitor. Frequency is equal to 1 over the square root of the inductance of the capacity. And the frequency driver is equal to 1 over the square root of pi times 1 over the square root of 1 times 2 times, so frequency is equal to 1 over the 2 times pi times 1 over the square root of inductor capacity of the circuit vibrates produces the standing wave depending on the frequency of the drive of the wavelength oscillation wave of the geometry of the circuit. When resistance is not equal to 0, the resistance of the not equal to 0 circuit operates in sequence frequency depending on the capacity of the inductance of the capacitor cannot due to the impedance load, the impedance capacity, and such for the total impedance for the circuit, the impedance resistance of the impedance load, the impedance resistance of the impedance inductance, the impedance capacity is equal to resistance to the plus of the impedance load and impedance capacity equals resistor plus 0 equals 0 R. The circuit resistance, the current of the circuit, the ampere of the voltage of the resistance, the operating frequency of the frequency is 1 over the square root of the inductance capacity of the current head of the doubling value of resistance of the ampere is equal to the voltage over the 2. The resistor circuit head of the table over the range of frequency 1 minus frequency 2. The circuit head of the capability to select bandwidth. The circuit stable, therefore suited with a tune resonance for selecting bandwidth filter. Once the inductor or capacitor tuned circuit resonance for resonant frequency over the 1 frequency equals 1 over 2 times pi times 1 over the square root of the inductor capacity of the current of a maximum value ampere equal to the voltage over the resistance. Reduces the currents of the ampered voltage over the 2 times the resistance. The circuit responds with a narrow bandwidth 1 minus 1 with 2. The current reduces the ampered voltage over the 2. The resistance circuit will respond with the bandwidth 1 minus 1 with the conclusion. We have circuits, general series RCL circuits, impedance, roots, amps, dampering factor, resonant frequency, bandwidth, and quality factor. Second order circuit solution. This page is going to talk about the solution. Second order resistant inductor capacitor circuit with a second order solution responsibly complicated with a complete understanding of the different equations. This book will not require to know the you know about a differential equation to describe the solution, showing how to derive them. The derivations may be in another chapter eventually. The aim of the trip is to develop a complete response with second order circuit with the number of the steps involved with determining complete response. Obtain the different equations of the circuit, determine the resonant frequency, the damping ratio, obtain the characteristic equations of the circuit, find the roots for the characteristic equation, find the natural response for the force response, for the complete response for the discuss the steps one at a time. Finding differential equations, second order circuit with cannot be possibly resolved with obtaining the second order differential equation describing the circuit. We will discuss some of the techniques of obtaining the second order differential equation in the RLC circuits. Know that parallel RLC circuits are easier to solve with the ordinary different equations and voltage. Consequently, Kirchhoff's voltage laws and series RLC circuits are easy to solve using ordinary differential equations and current consequence of Kirchhoff's current law. Different methods of the most direct finding with the differential equation of the circuit with the performing nodule analysis, measure current analysis on the circuit with the scope of the equation with the input function. The final equation should contain only derivatives, not integrals. Variable method of the create with the two variables G and H can be either created in a second order differential equation. First, G and H are to be either with the inductor current with the capacitor voltage or both. Now we create with the first order differential equation. G is equal to the F times GH, which if the first order differential equation has the form as the inductor or capacitor voltage over the time of the K times the inductor or inductance capacitor voltage, or 1 over K times the distance of the inductor components capacitor voltage over distance time equal to the inductor capacitor voltage, whatever you want to substitute those in. The first, we substitute the second equation first, and we have the second order equation. Zero input impedance. Zero input response circuits are stable. The circuit, there's no forcing function, no current input, no voltage input. We can set up the differential equation as distance squared times amp over the distance time squared equals 2 times parallel distance instance, the circuit's distance input over the distance times time of the frequency of 2 open and amps times t is equal to the area of the rising characteristic equation circuit explained below. Characteristic equation. The characteristic equation of the RLC circuit is obtained using the operator method described below with the zero input of the characteristic equation. RLC circuit series parallel B source and source squared times the amp time of the resistor times the source input. Source amp over plus 1 over the inductor capacitor times the amp equals 0. The root characteristic solution we're looking for. Finding the characteristic equation. But obtaining the characteristic equation requires a little bit of trickery that we find with the creator, an operator source such as source x is equal to distance x over the distance time. Also, we can have the higher order operators such as source times x over the distance times x over the distance time 2, where x is the voltage series circuit, or the current in the parallel circuit with the circuit. So if we write the two first order differential equation of inductor components and capacitor voltage and our current, converting all the differentiations to S or all the integrations F1 into 1 over S, where carry out with the Cramer's rule to solve the solution. Solution to the characteristic equation given in terms of the resonant frequency of the damping ratio. The solution is equal to the current of the plus or minus the square root of the currents squared minus the bandwidth to open either with the two values. You would assume that the x is equal to AC to the ST. Solution completes the differential equation that can be considered a valid solution. We'll discuss some more above. Damping of the solution of the circuit depending on the type of the damping circuit is able to determine the relationship between the damping ratio of resonant frequency. Different type of the damping, over damping, under damping, and critical damping, over damping, and circuit over damped with the following condition is true. The circuit is less than the bandwidth, the frequency, and solution of the characteristic equation 2 distinct with the positive numbers given in the equation. Ampere times time of that is equal to the assumed solution differential, two values of the assumed solution. Now, if we're average, the higher the quality factor, the longer it takes for the oscillation to decay. Critically dampened. A circuit with a critically dampened damping feather ratio, actual damping, critical damping is equal to 1. In this case, solution of the characteristic equation with double the roots. The two roots are identical. Root 1 is equal to root 2 equal to root. The solution of the amp times of the A plus B times energy of the root times the time. The arbitrary with the constant AB with the damp circuit that typically have the low or overshot no oscillation quick settling time. Series of resistor RLC, the different equation with the simple tree with the constant voltage of the source V and the resistor R and the capacitor C with the inductor L. Alright, series LC, the different equation, simple tree with the constant voltage V with the resistor R with the capacitor C with the inductor L. Inductor is the distance time of the charge time of the distance time with the time squared plus the resistance time of the time distance charge time of the distance time plus 1 over the capacitor times the charge equals 0. The characteristic equation as follows. Inductor times the source squared with the plus the resistor source plus 1 over the capacitor is equal to 0. With the two roots, source 1 is equal to negative 2, source 1 is equal to negative 1 times resistance over 2 times the inductance plus the square root of resistance over 2 times the inductance squared minus 1 over the inductance times the capacity, and source 2 is equal to the negative resistance over the over 2 times the load. 2 times the inductance C minus the square root of resistance times 2 times the inductance time squared minus 1 over the inductance capacity. parallel RLC. Different equation for the parallel RLC with the resistor R with the capacitor C with the inductor L with the capacitor with the distance time of the volts of the distance time squared plus 1 over the resistance time of the distance volts over the distance time minus 1 over the inductance time of the volts equal to 0. The voltage graph of the circuit with the characteristic equation as follows, and shows the parallel RLC circuit on the left, sort of the right. The capacitor starts a source squared plus 1 over the resistance times the source plus 1 over the inductance equals 0. So with the two roots, the source 1 is equal to negative 1 over the 2 times resistance times the capacity plus the square root of 1 times 2 times the resistance capacity squared minus 1 over the inductance capacity, and source 2 would be negative 1 over the 2 times resistance capacity plus minus the square root of 1 over the 2 times the resistance capacity squared minus 1 over the inductance capacity. Circuit response. Once of these, the other different equation for the other of our critical equation for the need to assemble the mathematical form of the circuit response with the RLC to the different equations in the form. The FT be the function time of the RL circuit, and then natural response of the circuit response with the given the circuit with the 0 with the depending upon with the initial conditions value with the natural response of the circuit with the denoted as xn to the base at n times t. Natural response of the system satisfied with the unforced differential equation am squared a squared minus d squared to x d squared blah blah blah. Remember the equation of 0 input response with the discussed above with the defined with the natural response with the exponential equation function with s of the root of the characteristic equation with the circle of the region with the choosing the specific solution x to the nth. Natural response is based on the differential equation theory with just accept without proof at the time being with the solve the constant values using the system of the two equations, where x is the voltage of the elements of the parallel circuit, the current through the elements in the series circuit. The force response is the circuit of which the circuit responds with the input function, forcing function of the force response denoted as f basis f times t with the force response with the set of the two differential equations. Force response is based on input and functions to given this general solution. However, they provided the set of solution different output. Complete response of the circuit is some of the force response with the natural response system. Once we have the derive of the complete response circuit, we can say with the solve of the circuit whether we finish the work. In the second order circuit with the inductor capacity, whether there's no resistance of the circuit, will be 1 over sort of A is equal to 1/2 resistance capacity for the circuit parallel is equal to 0. Circuit would be undermade, and so the A is equal to 0, and the omega value is greater than 0. Mutual inductancy.